Okay, welcome to week 5 of research methods. Today we are going to finish up the chapter on psychological measurement. We talked about variables, constructs, theories, all this stuff during our last lecture. We talked about reliability, and we talked about how to measure reliability, and we talked about validity. And that is where we left off, several types of validity. So now we need to talk about measurement, okay, specifically scales of measurement. Okay, so we talked about variables, and we said that there are things that vary, okay? Now we need to also think of a way to measure them, and we talked about operational definitions, right? And that's defining something in such a way that we can measure it. Well, there's different types of measurement procedures, and that's what we're going to talk about. So measurement is actually a procedure for classifying individuals. Measurement is a way to assign people to basically categories or assign numbers to people. That's measurement. Okay, you have to do that for your variables. Okay, the process of measurement involves two things. Okay, you need to determine what are the set of categories, you know, for your variables. Do you have male, female, intersex, other, something like that? You have, you know, black, white, Latino, Asian, mixed, other, you know, those are variables. Or maybe it could be a variable like mood. What are your set of categories? Is it 1, 2, 3, 4, 5? Higher numbers indicating better mood, lower numbers indicating worse mood, right? So you need to determine what are the categories. Sometimes they really are categories, labels, and sometimes they are numbers, okay? And you need to determine the procedure for assigning individuals to those categories. So who gets a 1? Who gets a 2? How is that decided? Do they decide themselves? You know, who is, you know, middle class, upper class, whatever it is. What is the procedure for assigning these individuals? So we'll talk about those things. Okay, now let's talk about these, a bit more about measurement. Let's talk about the different types of measurement scales. Okay, there are different scales, different ways in which you can measure your variables. You can measure variables on what's called a nominal scale. Some variables, basically, they are nominal. And nominal simply means that it's in name only. So it basically means you have categories, okay? So in a nominal scale, it says it represents qualitative differences in the variable being measured. Like your major, right? You're a psych major, you're an English major, a math major, a physics major. Those are names, those are categories. Those variables are on a nominal scale. What can you do with a nominal scale? Well, you can determine if two individuals are different. You can determine, for instance, if, you know, if a psych major is different than an English major, and they are, right? You know that they're different labels. But you can't really compare them. You cannot really determine, let's say, how much more like psychology is than history, or how much more history is than English. That doesn't make any sense. So with nominal scales, all you do is assign people, or have them assign themselves to different categories, and you know that they are different in that way, okay, according to those labels. But you can't really compare them, and you can't determine if there's a difference, and you can't determine how large the difference is. You cannot determine the magnitude of the difference. So how much more is psychology than history? Got a typo there, but you can't really do that. Okay, you can't determine the, you know, how much of a difference there is. So with a nominal scale, we're talking about variables that refer to categories, to put it simply. Nominal means name, okay? These are just names, you know, black, white, okay? Middle class, upper class, lower class, male, female, you know, ethnicity, you know, whether, or let's talk simply like race, because it's more easy to understand, right? It's a simpler variable, even though it's not really valid, but you know, black, white, Latino, Asian, you know, that kind of stuff. Those are variables on a nominal scale, okay? So that's what we mean by that. And you will have variables in your survey, when you develop your own survey, that are on a nominal scale, because you will ask participants, you'll have demographic questions on there. You know, like what is your sex? And for that, you usually give them categories: male, female, intersex. You know, maybe you want to give an other option other than intersex. It's up to you. You might ask about, about ethnicity, like I said, Black, white, Latino, etc., or, or simply race. And maybe some other ones that have to do with, with your questionnaire or with your survey. So you'll have some of these. And, demographics are basically mostly nominal, okay? There's other types of measurement scales. There's also variables that you measure on what we call an ordinal scale. And with ordinal scale, we basically means that things are in a certain order, okay? So ordinal, think of the word order. So things are in a certain order. First, second, third, small, medium, large, right? So an ordinal scale represents differences in a series of ranks, okay? So things are in order. First, second, third, small, medium, large, right? Some of these, like small, medium, large, sound like categories. So you think that would be a nominal scale, but it's not a nominal scale because it's in a certain order, small, medium, large. It's not just Black, white, Latino, Asian, right? That's nominal, okay? Here, they're in a certain order, small, medium, and large, okay? You can determine that there is a difference among these, right? Small is different than medium, medium different than large, first to second and third, etc., right? You know that there's a difference, okay? And you can determine the direction of the difference. You can determine which one's bigger, which one's smaller, right? And again, I have a typo there. I did correct this. I just have the old version of the PowerPoint here. I guess I didn't upload the new one. But yeah, medium is less than large, okay? Or large is more than medium, okay? So we do know, the direction of the difference, but we cannot determine the magnitude of the difference. We don't know how different one is from the other. So we know that, medium is more than small, right? But we don't know by how much. It varies, right? If you go to Starbucks, they don't call it medium, but if you go to Starbucks, a medium might be, certain percentage bigger than a small. But if you go to McDonald's and you get a drink there or a coffee there, it's going to be different. Or if you're talking about like order, like people completed a race or something, and someone came in first, second, third, etc. The difference between first and second might be a few minutes, or it might be a few seconds. It can vary. So with an ordinal scale, what you have are things presented in ranks, right? They're in a certain order. You know that they're different. You know which one is bigger, which one is smaller, but you don't really know by how much. And I'm not sure you're going to have anything ordinal in your, in your survey. You might have something like that, but it doesn't come up that much. Okay, it depends on what you're looking at, but that's ordinal. And then we have interval and ratio scales. This might be a little bit confusing because we're going to talk about them kind of together because they are very similar. There's one difference between them. Interval and ratio scales. Here, what you're really talking about are things that are measured according to a number. Okay, so interval and ratio scales consist of a series of equal intervals like inches on a ruler. So inches on a ruler, right? 1, 2, 3, 4, 5, right? It could be, also a scale, like a mood scale, like from 1 to 5, again, right? Or let's say how much your weight is or your height, that's what we mean. These interval and ratio scales, they use numbers, okay? And whether it's interval or ratio depends on whether there is a true zero. Is there a real zero, okay? If we're talking about pounds, for instance, there is a true zero. There is a zero that indicates that there is no weight, okay? And that means that it's a ratio scale. So a ratio scale has a true zero, okay? But an interval scale has what we call an arbitrary 0 point. An interval scale has a zero, but zero does not mean that that there's nothing there. Like 0 degrees Fahrenheit, it does not mean that there's no temperature. It doesn't mean that there's no heat, okay? Or even 0 degrees Celsius doesn't mean there's no temperature. It doesn't mean there's no heat. It's just the point at which for 0 Celsius, that's when, water freezes. That's when it could snow. For Fahrenheit, that would be 32 degrees Fahrenheit. But it doesn't mean there's nothing. It doesn't mean there's no heat. There is still heat, right? If you want to have a ratio scale that, refers to temperature, right? Then that would be Kelvin, the temperature scale of Kelvin, where absolute zero, where zero means there's absolutely no heat, okay? So that's the difference between interval and ratio scales. One has a real zero, right? That means zero. And the other one has an arbitrary zero. It has a zero, but it's just a zero, and it doesn't mean that there's nothing there, okay? Now, what can you do with these, okay, with these interval and ratio scales? So first with the ratio scales, okay? So with a ratio scale, you can determine the difference between 2 points on a scale. So you can determine, right, the difference between, you know, 1 and 2. Well, there's a difference of 1. Difference between 1 and 3, there's a difference of 2. You can determine that things are different. You can determine basically the amount of difference, okay? You can determine with a ratio scale, you can determine everything. You can determine there's a difference, the amount of difference, the direction of the difference, which one's bigger than the other, right? You can do all those things with a ratio scale. Here's the thing, you can also do that with an interval scale, okay? Now, whether that's valid or not, it depends on who you ask. If you ask people who are, you know, true mathematicians and stuff, they will argue that an interval scale, you can't really do all that stuff with. You might hear a little bit more noise today because I have the doors open. Just to get some more air in here. So you might hear a little bit more noise. But so with ratio and interval scales, we're talking about things that are measured with numbers, okay? Except that the ratio scale has a real zero that means nothing. An interval scale does not have a real zero. The zero does not mean nothing, okay? But these are very useful, okay? Because you can do everything with numbers. You can calculate, you know, differences. You know, you can calculate, you know, mean, standard deviations. You can run tests, right? So interval or ratio scales are compatible with basic arithmetic. You can add them, you can subtract them, you can find averages, right? You can do your tests for significance. You can determine correlations. You can do all those things when you have numbers. When you have numbers, you can do all the math, okay? And that's what we do in statistics. We look for things like that. Okay, so they're suitable for statistical analysis, means, variance. You can do hypothesis testing, okay? You can do that with a interval or ratio scale when you have numbers. Now remember, we talked about an ordinal scale, okay, where you have ranks, okay? When you have ranks, you can't do basic arithmetic with that. You can't add first and second, right? You can't add small, medium, and large. You can't add them. They might be first, second, and third, 1, 2, 3 in order, but the one there doesn't really refer to something that, well, it refers to an order, okay? Difference between 1 and 2 could be anything. So you can't really do math with that. And you can't really do that with a, you know, with nominal scales either. You can't do math with nominal scales. So you're gonna have a variety of things. Yeah, you'll have some things that are nominal. You might have some things that are ordinal. You know, maybe you'll have upper class, middle class, upper class, middle class, lower class. I think I mentioned that before as a nominal thing. It is not nominal. That's in order, right? We know that those that are upper class have more money than those that are middle class, and middle class has more money than those that are lower class. So that would actually be ordinal, and you might have that as a demographic. But the difference between them can vary depending on how you define middle and upper class. Okay, so that's ordinal. You can't really do arithmetic, basic arithmetic with that if you just use the categories. Now, if you use income, okay, you know, then that would be ratio. Remember that ratio has a true zero. If you use income and somebody puts 0 income and somebody else puts 100,000, you know, that's their income, then you can do the math on that, right? You can determine the difference. You can, you know, do all sorts of things. But if you just have middle, upper, lower class, then there's, you know, don't really know the difference, and you can't do any real math with that. By the way, the distinction between an interval and a ratio scale is not always clear. When you have these interval and ratio scales, the only difference is one has a real zero, the other one does not. A zero meaning that there's nothing. But it's not really always clear which is which, okay? Like for instance, you know, well, we'll get to an example in a moment, okay? We'll leave that discussion for, it won't be a discussion, just be a lecture, but I'll tell you more about that in a moment when we get to an example, and we'll see, you know, what it is, okay? Now, normally I would ask you guys to tell me what do you think it is, but since I'm just recording the lecture here, it's just, I'm just gonna tell you, okay? Selecting a scale of measure, okay? So, so here's the thing. We talked about this already, but you know, what kind of variables are you gonna use and how are they gonna be measured? What is your scale gonna be? So what is the scale's ability in comparing different measurements? I just mentioned this right now, but you know, here it is again. So with a nominal scale, right, it reveals whether you have differences, and that's all it does, okay? There's a difference, you know, between males and females, okay? That's it, okay? That nominal, that's all it tells you. Ordinal, things are in a certain order, okay? So you know that things are different and you know that one is bigger than the other. You know, it's like first, second, small, medium, large, upper class, middle class, right? So you know there's a difference and you know which one is more, which one is less. That's what you can do with ordinal, but you can't do any math with ordinal or nominal. Interval or ratio scales, you're talking about measuring things with numbers, whether you're talking about, you know, pounds, inches, you're talking about height, or maybe you're talking about, you know, some Likert scale question where you have, you know, a scale from 1 to 5 that determines mood, right? With 5 being great mood and 0 meaning awful mood, right? You know, you have there a, that's a scale. It also has numbers. A lot of people would argue that's an interval scale, but see that it's not always clear. I'll give you an example in a moment. So with interval and ratio scales, just to make it simple, right, there are numbers, you can do all the math, you can run the statistical tests, but remember, the ratio scale has a real 0 that means nothing. The interval scale does not. The interval scale might not even have a 0, by the way, okay? So the measure you select affects the ability to describe the relations between the variables. It affects what you can do, whether you can, you know, just report, you know, how many there are of each, or you can actually do a correlation, or you can do a, you know, calculate a mean, a standard deviation. Well, it depends on the kind of measure that you have, okay? But usually you'll have a variety. You'll pretty much, I'm sure you'll have nominal stuff, okay? You might have ordinal, maybe not. You're gonna have ratio stuff and you'll probably have interval stuff, okay? You need to know the difference between these. Now here's an example for you guys. Here's a Likert scale, okay? These are very useful for psychology, for measuring things that have to do with psychology. This is the Rosenberg 1965 self-esteem scale. It probably has been updated now. There's probably a newer version of it, but it's 10 questions that you answer on a scale of 1 to 4, 1 meaning strongly agree, no, 1 meaning strongly disagree, 4 meaning strongly agree, and you answer these questions. You know, the first one there asks, I feel that I am a person of worth, at least on an equal basis with others. If you strongly agree with that, you put a 4. If you strongly disagree, you put a 1, or you could be somewhere in the middle. And you do this, right? You answer all those questions, and it even tells you how to score it at the bottom, okay? And the point I bring this up is, well, what the heck is this? Is this nominal? Is this interval? Is this, you know, is this a ratio scale? Is it ordinal? What is it? So remember, nominal is name only. Ordinal is ranks, or things in a certain order. And we have interval, which uses numbers but doesn't have a true 0. And we have ratio that uses numbers but does have a true 0. So which one is it? Now, as a psychologist, I would argue that this is an interval scale. Okay, it uses numbers. You can determine the difference between 1 and 2, right? You can determine which one is bigger than the other, right? You know that there's a difference. 1 is different than 2, 1 is different than 3. You know, and you can do your statistics with this, okay? But does it have a 0? It doesn't even have a 0. What if it did have a 0? What if 0 was strongly disagree? That's not a true 0, so it cannot be ratio. I would argue that it's interval as a psychologist, right? But as I said before, a true mathematician or someone who, a true statistician would say that no, it's not even interval. It's definitely not ratio. It's not even interval. You know what they would say? And this might be a bit confusing to you guys, but they would say it's nominal. That 1, that strongly disagree, and 2 is disagree, 3 is agree, that those are just categories. And that the difference between 1 and 2 isn't clear. And if the differences aren't clear, right, you know, then you can't really do statistics with them. Some person might indicate a 1, another person might indicate a 2. What is the difference between those two people as far as their self-esteem on a certain question, right? They would argue that the difference between 1 point for one person, the difference in 1 point might be different than the difference of 1 point for another person. In other words, the difference between 1 and 3 means something different for person A than it would for person B, and they would argue that it's nominal. But you know what? You know, I'm a psychologist, and you guys are doing a psychology-related project, and we're going to treat it as an interval scale, okay? And we're going to do all the statistics, the math with it, because that's what we do with this, okay? And you'll run into a lot of useful things like this. Some of you are interested in self-esteem. Some of you maybe are interested in mood, and some of you might be interested in aggression. And if you do your research and you look up research, you'll find some good measures out there. You don't have to create your own aggression scale, your own mood scale, your own self-esteem scale, right? Some things have already been determined, and you have to find those scales. Or if you're having trouble, you know, then I might be able to help you locate something. You know, we'll call those things interval scales. They're very useful, okay? They help measure one thing with several questions. And we have to do averages. We have to run, you know, we have to do these statistical tests. We treat it like an interval scale. But a true statistician would say that it's not, they would say it's nominal. So there is some disagreement there, depending on who you ask. However, what you have to know and the way you have to understand this is based on what we just talked about, the difference between a nominal, ordinal, interval, and racial, okay? Never mind the little kind of, you know, dispute there, the argument, the little controversy there. Don't worry so much about that. I just thought I'd share that with you guys. There are different modalities of measurement as well. So different ways, so not just with the numbers, the categories, but different ways in which you can measure people. Like you can give people a self-report, okay? You guys know what a self-report is, a survey, a questionnaire. That's what you guys are gonna develop, your own self-report. It goes by different names. Self-reports measures ask participants direct questions to study behavior. It doesn't always have to be behavior. It could be, you know, things that they believe or things that they feel as well. But it's a direct measure, right? You ask them, you know, how do you feel on a scale of 1 to 5 about your ability to do math? Or how good are you at math? You know, rate your self-esteem on a 1 to 5 scale or something like that, right? Or just something like, you know, what is your sex, male, female, other? Those are all self-reports. It's basically when people answer questions from a questionnaire, from a survey. So it's a direct measure. You ask people, they tell you, but validity is dubious, right? It's whether it's valid, whether, you know, people are, whether it's really measuring what you want it to measure, that people can argue about. Because of course, on these self-reports, these questionnaires, as you learned from Psych 101, people can lie, people can misrepresent themselves, people may not remember. So they have all sorts of problems, but that's a self-report. You guys should know what that is already. There are also physiological measures, okay? Physiological measures are based on manifestation of an underlying construct. Okay, let me explain that. Physiological measures is basically when you measure something biological, okay? Like, let's say you wanted to determine if somebody, let's say, is anxious, okay? So anxiety is your construct. How are you gonna measure that? You're gonna use a physiological measure. Maybe you look at galvanic skin response, which is basically when they measure the electrical conductivity of the skin, because neurons communicate with electricity, and you know, when you get sweaty and stuff, you know, you're basically, that increases conductivity, things like that. MRIs, right, when they, you know, they scan your brain, they're looking at something physiological, right, trying to determine which part of your brain you're using. Let's say when you read a book or when you do something, depending on what you can do there in that MRI. Maybe you can look at a book or a tablet or something. Well, I don't know if that's the case. I don't know if the machine will work with it, you know, you having a tablet inside, but maybe you can look at a book or something like that. So these provide objective measures. You're looking at something that people can't really fake. Okay, well, that's arguable actually, but you're looking at something physical. Okay, so it's subjective. It's not that people are telling you, it's you are just measuring these things as they are responding. Okay, but they require expensive equipment, these physiological measures, and they may not provide valid measures of construct. So expensive equipment, yeah, the galvanic skin response, you know, there's something that allows you to measure that. It's a machine, right? You can look at EEG, the electroencephalogram, measure, brain waves. You can look at people's brains with the MRI. Those are big machines that may cost millions of dollars. You can look at heart rate, blood pressure, that kind of stuff. And there's some cheaper things you can buy that can measure your blood pressure, for instance. May not be more than like $50, but there's, also some expensive ones that cost more. The cheaper ones probably don't measure things very well, are not that accurate probably. So it requires you buying expensive equipment, and they may not provide a valid measure of the construct. Is anxiety really, are you really tapping into anxiety when you measure somebody's galvanic skin response, when you measure the electroconductivity of their skin? Or maybe you look at their heart rate. If it goes up, that's supposed to indicate that they are nervous, that they're anxious, they're stressed out, or maybe they're fearful. Is that a valid measure of the construct of the thing you're trying to measure? It can be argued that perhaps it's not, okay? But those are physiological measures. You use basically some physical measure, usually involves using some machine. With self-report, it's just a questionnaire, okay? Some survey. You can do it online. You can do it paper and pencil, but you guys are going to develop a self-report, okay? There are also behavioral measures. Behavioral measures, well, that's when you look at behavior and you check it off, okay? Behavioral measures are based on overt behaviors that can be observed. So when you do an observation, well, you use behavioral measures, right? When you observe people, you need to look for things that you can see. And what can you see? You can see behavior, okay? You can see if someone's pushing or hitting someone, if someone is playing, right? Or they're just sitting there quietly. You can observe behavior. So, you can just check things off, okay? Look at the behavior. Behavioral measures provide researchers with many options, right? It's possible to select behaviors that seem to be the best for defining and measuring a construct. So if you're interested in aggressive behavior, right, or aggression, that's a construct, okay? Well, what behavior counts as aggressive behavior? So you look for that, maybe shoving, hitting, whatever it is. You can have many options, right, to select things that, count as aggressive behavior. Problem is, behaviors may only be a temporary, or situational indicator of the underlying construct. Maybe the behavior is only temporary, or maybe you see a little bit of pushing or something like that. That might be temporary. Maybe the person doesn't always act that way. Or maybe the person hits somebody, but maybe they don't always act that way. Maybe they're not really aggressive. It's just that particular day, things are working out a certain way. Maybe they're not feeling very good, or they're upset, or whatever it is. And that's why they're showing that. Maybe they're not really aggressive. Or it could be situational, right? It could be that somebody's picking on them, and that's why they're behaving that way, but they're not normally aggressive. But behavioral measures are basically just when you look at behaviors. You do an observation, you look at behavior, you can check it off, or you can rate things or give or assign numbers to things. That's what a behavioral measure is. You look at behavior, and there's different ways, of course, to record that behavior. And we'll talk about how to do observations later, and you'll see that they're a lot more complicated than they first seem, okay? You don't just observe people and check things off. You can do that, but there are usually other rules. And an observation is not as simple as it seems, but that's a behavioral measure. You look at behavior. You can use multiple measures. It's a good idea to use multiple measures, right? Meaning that you can do, maybe a self-report and also have physiological measures, and maybe also have, behavioral measures, right? If you use multiple reports or multiple measures, right, that provides more confidence in the validity of what you're actually looking at, right? So if you have a questionnaire that says that this person's aggressive, and also you have an observation, you have behaviors that also tell you the person's aggressive, right? And you have physiological measures, then it probably, there's more validity to the claim that this person is probably aggressive. So it's good to use multiple measures, right? But it can also introduce problems, right? It makes the statistical analysis more complex, right? More difficult to interpret. What do you do, right? You have a measure, right? On a questionnaire, you have behavioral measures, and you might even have physiological measures. So you have to run 3 different kinds of tests. What if they don't agree, okay? Or what do you do, right? There are ways to handle that. Believe it or not, there's a way to there's a way to limit that problem. A method for limiting that problem with measurement is you can combine the measures into a single score. You can combine the behavior measure, the physiological measure, and the self-report measure under certain conditions. You have to run some tests first. You have to check the extent to which they correlate with one another. And if they correlate highly with one another, right, different measures, that means that you've measured the behavior 3 different ways and that it's reliable. You're seeing the same thing. And then you can combine the measure, okay? You can add up the scores and divide by 3 to get an average if you have 3 measures, for instance. But yes, that's how, it can make things more complex. Now, if you have desynchrony, the lack of agreement between 2 measures, right? If the behavior measure, your self-report measures don't really agree, then you can't really combine them. And that makes things more complex. You have 2 different measures that say different things, and therefore you have to run different tests. It's like you have to do all these statistical analyses twice. You have to treat these measures differently. You have to treat them separately. You can't combine them, okay? But it's useful to use multiple measures, but it doesn't always happen because it complicates things. There's other issues with measurement. You can also have what's called a sensitivity. You can have measures that are not sensitive enough, or you can have what we call range effects. Let me explain what a range effect is, okay? So with a range effect, that means that we have a problem where the score seems to be in a certain range and there may not be enough variation. When you use measurements, okay, you want variation, okay? Because when you have variation, you can determine differences. You can do statistical analyses. If everyone scores the same way, it's a problem, okay? So you can have different, range effects. You can have what's called a ceiling effect, where all the scores seem to be high, basically. All the scores are at the high end of the measurement scale. It's like when you give people a test, a psychology test or something, and it was too easy, and it's like everybody scored in the 90s, okay? How can you really determine let's say if there's differences between males and females, or a correlation, let's say, between the test score and the person's attendance or something, if you have a measure of that, all the scores are really high. That's a problem. It doesn't really lend itself to much analysis, okay? There's just isn't enough variation there. You need variation for analysis, okay? And if there's a ceiling effect, that means all the scores are too high. If there's a floor effect, that's the opposite problem. All the scores are too low. All the scores are at the low end of the measurement scale. So it allows little or no possibility of decreases in value. And again, it becomes a problem when you want to compare groups or you want to do correlations. If all the scores are low, it's kind of hard to determine that, okay? It's like when you give a test and it was too hard. And let's say that everybody scored in the 20s or something like that. Hardly anybody knew anything, or maybe even lower than that, okay? That would be a floor effect. If there's not enough variation, then it's hard to run statistical analyses, okay? And if the scores are too high, if all the scores are really high, that's a ceiling effect. If all the scores are really low, that's a floor effect. And that can happen, okay? They're more likely to happen with things that like are physiological, let's say where everybody scores the same way, like how fast is eyesight? How fast are you at like seeing something on a screen? You might get scores that cluster in a certain range because people's eyesight, I mean, it's physical, it's physiological. And if your eyes work properly, they all kind of work the same way. Now, some people are a little bit faster than others, but my guess is that, we're probably similar in the speed at which we can detect things. Some of us may be a little bit faster than others, but there probably isn't a huge difference in scores. The difference might be in the order of, milliseconds, not seconds, okay? So here's the thing, going back to this, because I talked about a range effect, so there's sensitivity and range effects. Now, what's the issue with sensitivity? Sensitivity, because I didn't define it there, when you have an issue with sensitivity, that means that your measure is not sensitive enough, okay? In other words, it's not good enough to really detect any differences, okay? And that could lead to a ceiling effect or a floor effect. You don't have a good measure, okay? So lack of sensitivity can lead to range effects. You can also have artifacts. Artifacts, like things that basically kind of mess up the study. Artifacts can include things like experimenter bias, participant reactivity. So artifacts are extra things that kind of mess up your study. Okay, an artifact, a non-natural feature accidentally introduced into something, right, being observed. It doesn't have to be an observation, but an artifact is just something extra that affected the study, that became a part of the study, that was accidentally introduced. Okay, you didn't mean for it to happen, but it did. It's a non-natural feature of the study. In other words, it's something that shouldn't be a part of the study. An example of that is experimenter bias, right? Where the measurements are influenced by the experimenter's expectations regarding the outcome of the study. Okay, so maybe the experimenter, let's say, is interested in whether, let's say, acupuncture is helpful, let's say, for reducing pain. And the experimenter, let's say, is just, you know, really nice to participants, or tells participants that they're trying to determine if, you know, if acupuncture is going to reduce their pain. Tells them what the experiment is about to some extent, right? Then you've introduced the problem, okay? You've introduced an artifact. Now, experimenter bias is basically when the experimenter does something to make the results work out in his or her favor, okay? So you basically tell participants that, yeah, you're interested in pain and whether acupuncture helps, and just with what you tell them, you kind of give them the hint that, yeah, we expect this to work. This is going to work, and therefore they act like it works. Okay, that's experimenter bias affecting the study. Or let's say if we're talking about an aggression study, maybe this is a little bit more clear of an example. If we're talking about an aggression study, let's say the experimenter has, he wants the people who are an alcohol and aggression study, okay? Because I talk about that a lot, because that's my background. You know, the experimenter, let's say, has some people consume alcohol to see if how aggressive they become afterward. And then there's others that don't consume alcohol, and we also measure their aggression. There could be experimenter bias in the sense that maybe the experimenter, for instance, treats those that have been consuming alcohol a bit more harshly to make them more aggressive. Without even knowing it, he might do that. That is experimenter bias. And that is what happens when the experiment, that's what can happen when the experimenter knows who's actually gotten alcohol, who has not, when the experimenter knows too much about the study. Okay, so you usually need a third person to reduce this problem. You need an assistant who isn't so invested in the outcome of the study, and let that assistant run the study, so to speak. So it's not influenced so much by the experimenter, because the experimenter is the one who designed the study and expects things to work out in a certain way. He or she can still be involved, but you need to remove them a little bit from critical features of the experiment. You can limit experimenter bias by standardizing the experiment, where everyone is treated the same way, okay? Everyone gets the same instruction, and you adopt the same tone, the same behavior for all participants, right? That's one way you can limit experimenter bias, okay? Everyone gets treated the same, so the experimenter should not treat certain people worse or, you know, better than others, okay? Or you can do a single blind study. A single blind study is a research study where the experimenter knows the treatment given, but the participants do not. Actually, with the single blind study, it's better to have it the other way around. A single blind study where basically you make it so the experimenter doesn't really know, you know, the independent variable, who's getting what, right? Who's getting alcohol, who's not getting alcohol. You make it a single blind study. It's best if it's the experimenter who's kept in the dark. Single blind means that somebody's blind, either participants or the experimenter, right? So with a single blind study, yes, you could keep the participants in the dark. That would be a single blind study. But it's also good if you keep the experimenter in the dark. Now, if both the experimenter and the participants are in the dark, that's what we call a double blind study. In a double blind study, neither the experimenter or the participants know the expected results of the study, so they can't really influence the study in a given way, okay? Single blind study means that somebody's blind, and if you're gonna have somebody blind, usually it's the participants that are blind at the beginning and not the experimenter, but it could also be the experimenter. But usually if the experimenter's blind, the participants should also be blind, so that would be double blind. So single blind means that somebody's blind, it's usually the participants, okay? And double blind means both the experimenter and participants are blind. Sometimes I get a little bit convoluted when I talk about these things because, well, you know, that's what happens when you're trying to think of examples. The results can also be distorted by the actions, actions and responses of, of participants. So you can have also different artifacts like demand characteristics, and these are all easy things that you probably heard of from 101, Psych 101. Demand characteristics refer to any potential cues or features of the study that suggest to participants, the purpose and the hypothesis of the study. So it suggests to participants what's expected and therefore how they should behave. Demand characteristics influence the participants to respond or behave in a certain way. So you give participants a clue, right? That this study is about happiness. Therefore, you should act happy. Or this study is about aggression. And you don't want to be aggressive, so you behave in a non-aggressive way. Demand characteristics can work for you. They can work against you, okay? So participants basically get a clue about what is actually happening or what's expected, and therefore they respond in a certain way. They act a certain way. It's like you're demanding it from them, okay? Somehow they understand what you're looking for. But they may not give you what you're looking for. They may give you the opposite. Reactivity is when the participants modify their natural behavior in response to knowing they're in a study. Like, let's say, especially if they're in an experiment, they know somehow that you're going to be messing with them in some way because it's an experiment. And because of that, they don't behave naturally, okay? Maybe they don't behave as aggressively as they normally would. Maybe that's what you're interested in. Or maybe they don't, they're not as happy as they normally would be, and you're interested in happiness. Reactivity is just basically when they react differently because they know that you're watching them, they know you're going to be messing with them, that kind of stuff. And when it comes to reactivity or demand characteristics, right? When participants get a clue about what you're expecting from them and they behave in a certain way, they can behave in any of these ways. They can adopt what's called the good subject role, where they do things to help you out, so to speak. So they behave in ways that will confirm your hypothesis, okay? That's the good subject role, right? They do things that will lead to the outcome you're looking for. Or the negativistic subject role, where they will act in the opposite way that you want them to behave, right? Sort of to screw with you, that they basically, don't want to, they find out that you're studying aggression. They don't want to seem aggressive, so they act very non-aggressively. Even, let's say, if you've given them some alcohol to drink or something, or done something else to increase their aggression. They find out that's what you're looking for, and they give you the opposite. That's the negativistic subject role. The apprehensive subject role is where the participant just wants to present themselves in a good light, like a good person, and that may help you or that may hurt you as far as, your hypothesis, but they're apprehensive, okay? They just want to present themselves in a positive way. Or the faithful subject role. That's what you actually want. You want the participants to follow the instructions to the letter. You want them to do what you tell them to do, right? You want them to be a good subject, right? A good participant, so that everything works out, okay? Well, it doesn't always work out, but the faithful subject role is the one that follows directions, follows instructions, and does things the way you tell them to do them, okay? And that is it, you guys. So let me stop recording.